So this is part 4 to 4.1, the never-ending section. But we're going to talk about non-homogeneous solutions now. So we have a theorem. It's called the superposition principle for non-homogeneous. We've already seen in the previous parts of this section a superposition principle for homogeneous. So now we're going to look at one for the non-homogeneous. So if YPI denotes a particular solution to the DE, so basically YP1 here is a solution to this GE, okay? YP2 is a solution to this DE. Notice how the left side is identical. So basically we just have all these different solutions, and it goes down to K. So basically if YP is the solution, the sum of the solutions, then it's a particular solution to the same DE on the left, but it's the sum of the right side. So basically our non-homogeneous is that. So we're going to be going backwards. Given this in our problems, we're going to go and separate it, find a solution, add them up, and then that's a particular solution to this entire thing. I'm going to prove this really fast, only because it uses linear operators. It's a really fast, quick proof. So before we do that, though, let's recall what a linear operator is. So Ly is our linear operator. So that's what the linear operator is. So we're going to start with the linear operator on a particular solution. So we want really the linear operator on y1 plus y2 plus yk. Oh, I guess we're calling them p2, p1. Let me re-index those just to match these. Particular solution 1 plus particular solution 2 plus particular solution k. Well, they are linear operators, and we can basically distribute. Since each of these, by definition of what was given, each of these are the solutions to that DE. Each of these are G1. This one is G2, so just substituting each of them. And that's it. We've proved that the DE, the particular solution, is that. Let's look at an example to see how we can use this. We'll be learning lots of different techniques, and this is basically just the first one. And to be honest, we don't see this much later on in this textbook. There's a lot of skills here that will help in our understanding of differential equations. Okay, let's start off with B. I'm stepping us through the problem here with these sets of questions. So part A, we want to find a particular solution. We'll call it find YP for particular to... Okay, so I haven't given you any techniques really to solve this. So since I'm asking you to solve it, basically all we have to do is stare at it real hard, and basically guess and check the solution, okay? So what can y be that I can take the second derivative and plug in y and get a solution? So if, for example, y is 5, don't you think that second derivative will be 0? Yeah. And then when we plug it in, this is 0 plus 2 times 5 is equal to 10. So there's a particular solution. There's my YP, number 1. We want to call it that. Let's do it again. Find the particular solution for the same DE on the left, but my g of x is minus 4x. So equals minus 4x. Okay, so again, what is y? What's a solution to this? It's going to be a guess and check, such that when I find my second derivative and plug it in, I plug in y, I get a true statement. Well, let's try it, what we just did last time. Y times what is minus 4x? How about minus 2? And we'll need an x there. So the first derivative is minus 2. The third derivative, the first derivative is minus 2. And the second derivative does 0 out. So that, I think, does work. Yep. It works. That's a solution. And part C now says find the particular solution to same left side. So it's basically adding 10 and minus 4x. So remember, by the superposition principle, my YP will be the sum of these two. And if we want, we can check. Okay, so let's check it. Make sure it works. So YP prime is minus 2. YP double prime equals 0. So Y double prime is 0 plus 2 times Y. Does that equal to 10 minus 4x? 10 minus 4x equals 10 minus 4x. Yep, it is true. Therefore, YP is our solution. And part D, can we do it independently? We want to find YP for... So they're just asking us up front. We're not getting led through it now that we understand it. So 1, we're going to find YP1. Looks like we want that to 0 out. So YP is 4x. YP prime so we get 0 plus 2. True. And then now the second one. The second particular solution looks like 5/2. We get 0 and we get 0 again. So now that we've found the two G1 and G2s, YP1, YP2, my particular solution for the sum is the sum of those two YPs. And that's it.